Hello everyone, welcome to the Maths Hub. For the last class, we talked about maximization problem under linear programming. So today we're going to be treating minimization problem. So if you haven't liked and subscribed, ensure you do so and turn on the notification bell to get notified whenever I drop more videos like this. That being said, let's get into the activity of today. So, example 2 says, a metal alloy is to be made at a minimum cost of 2 other alloys, costing 400 naira per ton and 200 naira per ton. 6 tons of the expensive one contains 3 tons of copper, 2 tons of metal A, and 1 ton of metal B. 6 tons of the cheap one contains 1 ton of copper, 2 tons of metal A, and 3 tons of metal B. The final alloy is to contain at least 6 tons of copper, 8 tons of metal A, and 6 tons of metal B. Make a mathematical model to obtain the equation relating to the weight of B. Find the number of tons of each alloy which must be used at the total cost. So this question is a little bit lengthy. Let me write out the things we will need. So, it says a metal is to be made at a minimum cost of 2 other alloys. So, we know we are dealing with 2 alloys. It said now, costing 400 naira and 200 naira per ton. Alright. 6 tons of the expensive one. Now, take note of the statement. It says 6 tons of the expensive one. So, let's say, let the expensive alloy be represented as X as usual. Then if you read further down, it said the statement is made about the cheap one. It says 6 tons of the cheap one. So there's also a cheap one. Let the cheap alloy be represented as Y. So looking at this, stating they have 2 alloys, which is expensive alloy and cheap alloy. So from this statement, we can start bringing out the things that are under them. So from the beginning, now I said they are costing 400 naira and 200 naira. All right, we have our cost to be 400 for X plus 200 for Y. All right. Now I say 6 tons of the expensive one contains 3 tons of copper. Represent this as 3x. Alright. Then 2 tons of metal A, 2x. Then 1 ton of metal B, 1x. This is for the expensive one, all represented by X. Now, it says 6 tons again of the cheap one contains 1 ton of copper, 1x, 2 tons of metal A, sorry, this will be 1y, 2y, and 3 tons of metal B. So, for expensive alloy, they use 6 in total. That's why it says 6 tons of the expensive one. And for the cheap one, they use also 6 in total. That's why it says 6 tons of the cheap one. So, this is 6, this is 6. Now, we continue. It said the final alloy is to contain at least 6 tons of copper. Note, this is for copper, this is for metal A, this is for metal B. And the final alloy is to contain 6 tons of copper, alright, 8 tons of metal A, and 6 tons of metal B. They were asked to make a mathematical model to obtain the equation and find the weight of B. So, we can say this is for copper, this is for metal A, and this is for metal B. Now we've known this, we can note, as usual, this is subject to. Remember from our maximization problem that we treated, this is always our, there it was profits because we're maximizing profits. Now this one we're minimizing costs subject to this. So we begin. Solution. taking them one by one. From copper being 3x plus y equals to 6. Now, for maximization, because we're told to maximize, so we can use up to that extent or less than it. Now, for minimization, we will use up to that extent or greater than it. It is the inverse. So this should be greater than or equals to, this should be greater than or equal to, this should be greater than or equal to, because look at it this way. Want to make a profit of 600 naira, and we are giving, let's say, information like this. To attain this, either we use the materials enough to get that 600, or we use less than it to be efficient and effective that will also give us the same amount. Now, inverse is the case for minimization. We have a cost that we don't want to spend above this amount. So we have to do everything possible to get that thing we need at this particular amount or greater than it, which is the inverse. So this will be from copper. They will say 3x plus y equals to what? 6, when x is equals to 0, y is equals to question mark. Substitute 3, 0 plus y equals to 6. 3 times 0, 0 plus y equals to 6. 0 plus y is equals to 6. Alright. Now, when y is equals to 0, x is equals to question mark. 3x plus 0 equals to 6. 3x is equals to 6 over 3 over 3. X is equals to 2. So we've gotten the constraint for copper. Now do the same thing from metal A, which we are given to 2x plus 2y equals to 8. When x is equals to 0, y is equals to question mark. So that's 2, 0 plus 2y equals to 8. 0 plus 2y equals to 8. 2y is equals to 8 over 2 over 2. Y is equals to 4. When y is equals to 0, x is equals to question mark. So that's 2x plus 2 open bracket 0 equals to 8. 2x plus 0 equals to 8. 2x equals to 8 over 2 over 2. Cancels each other. X is equals to 4. And for the last constraint, from metal B, which we are given to be x plus 3y equals to 6. When x is equals to 0, y is equals to question mark. So we have 0 plus 3y equals to 6. 3y equals to 6 over 3 over 3. Cancels each other. Y is equals to 2. Then when y is equals to 0, x is equals to question mark. So we have x plus 3 open bracket 0 equals to 6. X plus 0 equals to 6. X is equals to 6. So the coordinates now. So for copper, we have x, or let's begin. We have y equals to 6. X equals to 2. For metal A, y equals to 4. X equals to 4. For metal B, y equals to 2. X is equals to 6. So through this, we can draw our diagram. Just write it. So now we've done this. Don't forget your non-negativity. Very important. Very important. Non-negativity remains the same where x is greater than or equal to 0, y is greater than or equal to 0. So, given this, we have copper 6, metal A 4, and 2. The highest for y will be 6. Then the highest for x also is 6. No negativity. So, we can come this way. Y-axis. Say 6, 5, 4, 3, 2, 1, 0. 1, 2, 3, 4, 5, 6, x axis. So, when y is 6, x is 2. So, allow them meet. When y is 4, x is 4. We'll allow them meet. When y is 2, x is 6. We'll allow them meet. Now, this for minimization is different from maximization, because for minimization, we dealt with the innermost, something within. But for minimization, we are dealing with the outermost. This one is not outside because this one is more outside than this. This is more outside than this. This is more outside than this. This one is not outside. This is more outside. We are dealing with the outermost, because if you remember correctly, for maximization, here was our point A, because it was the starting. Point B was here because it's closest to 0 compared to this and this. Point C will be here and point D. But for this now, point A will be here because it's the outermost, just like the beginning of everything. Then coming down, we cannot come here because this is more outside. So coming down, this will be point B. Still coming down, don't allow it to come inside. Still coming down, touches here, this is point C. Still coming down, and this is point D. So from this now, we can know how to do our corner points. Remember, this is copper A, 6 and 2. And it says, okay, where 3x plus y greater than or equal to 6, 4 and 4, where 2x plus 2y greater than or equal to 8, and the last one, where x plus 3y greater than or equal to 6. Now that we've known this, we can do our corner points. So let's rub this off. So, alright, corner points. As usual, we have our element, we have our x, we have our y. Now, for this one, unlike maximization, that we wrote profit because we were trying to maximize profit. This time now, we're trying to minimize costs. We're trying to be effective in our work. So this, in addition, should give us a minimized cost, which we are to work with. So we have A, B, C, and D. 4 elements, A, B, C, and D. Now, for A has a touching of Y on this lane being 6. So for X to meet this Y line, X has to come all the way for this side and meet it at 0 in order to meet at Y junction 0. For B now, B is not touching Y, is not touching X. So we'll trace it. Dot, 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 dot. Trace it down also. Dot, 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 dot. So B now, we can say, since this is 3, this is 4, we can just say for Y 3.5. Then this is 1, this is 2, we can say 1.5. For C, just as B, we'll trace it. Dot, 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 dot. Okay, not smooth enough. to do it again. Let's begin from here. Dot. So this is 1, this is 2. It's close to 2. Should we assume 1.5 to make everything easy to do? For y, 1.5. Then almost close to 3. So we can say 3.3. And for D is touching 6 already for x. And for y to meet it, y has to come down to 0 to meet it. So we can begin. Now, from the beginning, the question says it has a minimum cost of 2 other alloys costing 400 naira per ton and 200 naira per ton. So these are our constraints: 400x plus 200y. So 400 open bracket 0 plus 200 open bracket 6. This is 0 plus 1,200 equals 1,200. For this, 400x plus 200y equals to 400 1.5 plus 200 3.5. So we'll get 400 1.5. That's 400 times 1.5, giving us 600 plus 200 times 3.5, giving us 700. So 600 plus 700 equals 1,300. Same thing. 400x plus 200y equals 400 3.3 plus 200 1.5. So 400 times 3.3, giving us 1,320 plus 200 times 1.5, giving us 300. So 1,320 plus 300 equals 1,620. And the last one, 400x plus 200y equals 400 open bracket 6 plus 200 open bracket 0. 400 times 6 is 2,400 plus 0 equals 2,400. Now, we've gotten all this. For maximization, I'm always referring to that because that was the first one we did. For maximization, in order to maximize profit, we chose the highest amount. But for minimization, we want to reduce cost to the lowest. This is 1,2, this is 1,3, this is 1,620, this is 2,4. So the lowest we are going to pick will be 1,2. Recall, X was representing the expensive alloy. Y was representing the cheap alloy. So from this, we can say the management should choose option A by producing no products of the expensive one and 6 units. So we can say no units instead of no products. No units. And 6 units of the cheap one to obtain a cost of 1,200. So that will be all for minimization problems. In our next video, we'll treat shadow cost under linear programming. If you have any questions you'd like me to treat on either on this or any other topics, you can drop it in the comment section. Bye.